What is this, elementary school? Okay. All right, anyways. So here we go. Finding binomial probabilities using your calculator. Okay. So you have the same problem here, you know. You find your NPQX. So your NPQX. Remember, it has to follow the 4 criteria. Make sure everything works for your 4 criteria. If we ask you, you know, if you have the binomial distribution, make sure you check those 4. So N, yep, there's 13. P is 80%, and that's the same for every free throw. So just because she misses one doesn't mean she's going to definitely make the next one. Okay. Independent. So my X starts at 0 and goes up to 13. So my N is 13. My P is 0.8. What's my Q? 0.2. My X is, well, we're going to say 0, 1, up to 13. But this X specifically is going to be 9. Now, if the quiz or the test says that you have to use your formula, show your formula substitutions, and you have to show your formula substitutions. And then once you use your formula substitutions, you show me what you plug in. You can either check the answer in the back of the book, that table A2, or you can put it in your calculator to check them. Okay. If you show me the answer and you do not show what you plugged into the formula, you will not get any credit. If it says that you have to show formula substitutions. Okay? Does that make sense, everyone? So make sure you know how to use the formula. All right, so your calculator. It is menu, 5, there's your probability, and then distributions, which is another 5, and then you're going to scroll down, but you don't have to scroll down all the time. We'll just scroll down once. What did I do? So let's take it from the top. Menu 5, 5, and why did it move? And you see where D is binomial PDF. That means a probability distribution function. That's what it means. So it's 5, 5D. And you can see that the number of trials, N, which in this case is 13. The probability of success is 0.8. And the X value, it says optional. In this case, it is 9. And there it is. Mm-hmm. Yeah, if you know what it is, you only fill in what you know. Now, I've tried to do it such that, you know, if it says like greater than 9, okay, or at least 9 or whatever, and, you know, 9, 10, 11, 12, 13, but you can't do it such that it's just a snapshot of the 14 values. You have to do one at a time. And, okay, so there's your 9. So you got 0.154, okay, 0.154, because remember, 3 decimal places. So back to Destiny's question here. So if you wanted like 9, 10, 11, 12, I just do this, and I go back and do not 110, but, you know, 9, 10, 11, 12. That seems to be the easiest way if you have multiple. Okay. Now, the other way where it can show all of the values that we're going to look as we get down to the bottom here is you still do the same thing. Menu, 5, 5D. See how if I know 5, 5D, it brings me right to it? Okay, so it might be a nice little thing to have in your notes. The number of trials is 13. The probability of success is 0.8. Now, the X value says optional. Just leave it blank. Okay, so if you just leave it blank and hit enter, see what it does there? It gives you all those values. So this is where you need to be able to interpret that the 8.192 e to the negative 10 is really 0.9 zeros and then 8192, so it's 0.000. So then, yeah, it brings you all the way to the end. See, now this is the tough part about it. See how I got to scroll all the way back? okay, to figure out what the values are. So you're going to have to put them in a table, all right, or really, keep track, all right, because look, it gives me all of them, okay, and this is all like in the back of table A2, where you have them listed in a column, okay, so that gives you every single value. So if you did need the first four, of course, you would go to all the way to the beginning, wherever that is, and just say, hey, the first four are 0.000. Look, the zero. See how all the zeros? It won't always happen that way, but this happens in this case. Okay. Now it says, is it unusual for Mary Kate to perform this poorly? There's two ways to determine that. So you got this in your notes. So you have your p-value. What is it? 0.154. Okay. So if you have a p-value that is less than 0.05, that is unusual. Okay? If your p-value is less than 0.05, it's unusual. So is it unusual for Mary Kate to make 9 out of 13 free throws? No, it's not unusual. Okay, because it's 0.154. All right, it's unusual if it's less than 0.05. So this is not unusual. Okay. All right, Adam inspects a different tub of quarters, selects a random sample of 10 quarters, unknown to Adam. 10% of the quarters are Canadian, therefore do not meet specifications. What is the probability that no more than one of the 10 quarters in the sample is Canadian? So identify again NX, P, Q. How many quarters are there? 10. Probability of success. Now, the success is that it's going to be a Canadian quarter. Okay, we don't want that to happen, but that's what we're trying to figure out because 10% of them are Canadian. So 0.10, therefore a Q is 0.90. Now you notice that when you plug into your calculator, you don't need the Q. Okay, the calculator knows, well, if I have 0.1, then the Q is going to be 0.9. So my X is right here. Probability that no more than one of the 10 quarters in the sample is Canadian. So no more than one. What X values would I have for that? 0 and 1. So 0 and 1. So plug in your calculator and get those two p-values to 3 decimal places. Mm-hmm. Didn't have to do another one. Yeah, like I said, I tried to do it with 0, 1 in the X values, and it didn't work. I mean, if someone can do it or find a way to do it that you put both of them in at the same time, please share. But as far as I know, you got to put the 0 in, get an answer, and then either go all the way back to 5D or just scroll up and change the 0 to a 1. So I got 0.348 and 0.387. Nope, 349. You have to round that 8. I got 0.38742. Right, for the second one? Okay. And 0.34867, so 0.349. Those good? Okay. All right, and then add those together. And there you go. 0.736. All right. Good. Any questions on that? Not too bad, right? So graphing binomial distributions. A lot of times they represent them graphically. Do you have this? All right, then we got to add it. You can put it right on your graph page. You can put it right on the top of your graph page. This one must have been deleted. from my notes. So graphing, binomial, this is good because it'll all be together. So you want to write, you got to write those sentences down. 59% of households in the United States subscribe to cable TV. You randomly select 6 households and ask each if they subscribe to cable TV. Construct a probability distribution for the random variable x, then graph the distribution. If you want to hold off on the table, you can hold off on the table. Just copy down the example. So if you already have the table drawn like that, that is okay. If you would rather have the table as a column, because that's what you're used to seeing, that's all right as well. And I'll show you on the graph page once I think everyone's done. I'm still seeing people copying. Okay, so with the table, what the heck? So with the table, if you want to have it as x, p of x like this, okay, that's all right as well. I don't know what's going to be the easiest for you guys to copy down. So either one, it doesn't matter. So we're talking about 6 households. So remember, your smallest value for x is 0, and it has to go up to 6. So in your calculator, do your menu, 55D, and get these values. Now, if you want to do it all at once, that's fine. You could just scroll over. If you want to do each one individually, that's fine as well. For the what? The n is 6. Yes. What's your p? 0.59. So maybe you want to have this here too. N, x, p, q. So your n is 6, your x is 0, 1, up to 6, 0.59, and then 0.41. But like I said, you don't need the q. I'm just going to fill in that table. 3 decimal places. The x is 0 through 6. All the possible values that can happen. So by rounding, you have 0.005, correct? And then 0.041, right? And then 0.148. And then I went all the way to the end. I just want to double check. All the way up then, I got 0.042. Working backwards, I have 0.176. And then I have 0.306. 0.283. And then 0.148, correct? So like I said, I did it the other way with, I don't know which way you did it, but I did it using all of them at once. Okay, 0.005, 0.041, 148, 283, 306, 176, and 0.042. Okay. Anyone get different values than that? So, I mean, this was only 6 values. Like if you have 10 values or 11 values, it gets really challenging to figure out where you are. Okay, and then make sure you scroll all the way back. Now, what I'd like you to do is I would like you to take the sum of p of x. I'd like you to find what that equals, because what should that equal? 1. Golden flu season. Get what? That's what you should have got. Oof. You put a number in wrong. So you should have got 1.001. Remember, when you're finding the sum of p of x, what range will I accept? 0.999 to 1.001. Okay, do you have those values? Yeah, well, that's what's going to happen. Now, the thing is, if you use the exact values, of course you're going to get 1. Okay? So if you do that, you say, oh, find the sum of these, of course it's going to be 1. But your rounded values, okay, are not always going to be perfect. And these are the values that we are going to use as if I just want you to find between 3 and 5. At most 2. At least 5. Then you're going to use these values. Okay? Now, graphing. And when you have your graphing, it's kind of tricky. Okay, I drew just a line here and then another line here. It's a little tricky in such that it's not just, okay, how many times can the 0 happen? All right, it's not like when you're collecting data and how many cats do you have, okay, or something like that. You're going to have to space out for your numbers. So don't put anything else in. Usually you have enough space to space out your x and your y. So meaning that I'm going to have 2 spaces for each number. I hope I have enough room. You will have enough room. Yes, I do. No, you got 2 of them, so 2 slashes. Okay, so I skip this first one and then have 2, 2, 2 with a little line, you see? If you did 2 here, fine, I don't care. Just make sure everything's spaced out properly. You can't do 2, 3, 2, 3, no good. It's all got to be the same width. Now, this first one is going to be your 0. And then 1, 2, 3, 4, 5, and 6. Right, you're making like a histogram. Yeah, and it says that the directions say graph the binomial distribution using a histogram. So we'll tell you that you're using a histogram. You put it just like I have it. Yeah, in between those 2. Because that 0 has to be the same width. If you have 2 spaces, you can put it there. That's fine. You know what I mean? The 0 has to have 2 spaces. If you're 1, 2, 3 all the way, have 2 spaces. And if you want to spread it out and you have 3 spaces, that's fine. Okay, not a big deal. Now, as you look your y, okay, or your p of x's, you can see the smallest is 0.005, and it goes up to 0.306. I do not, don't write this, I do not want 0.1, 0.2, 0.3, okay? So that's too scrunched together. You want to spread things out so you can see what's going on. So what would make the most sense would be to go up by 1, 2, 3, 4. I mean, you can go 5, whatever you want. 1, 2, 3, 4.2, 1, 2, 3, 4. I don't know how much space you have. You can either go up by, you know, like a 0.25, so to speak, or a 0.2. Okay, so you can go 4 or 5. Either one's all right. Just make sure you're very careful. Okay. This middle here, okay, how would I write that as a decimal? Okay, good. Yeah, just be very careful because it's not 0.5, it's 0.05. Okay, and this one here in the middle is going to be 0.15, and this one's going to be 0.25. Okay, as you try to do this. Because so many times I'd see the mistake that you have the 0.005, and you put in the half there. Right? All right, so with my 0, I have 0.005. Okay, so if that's 0.05, this is 0.025, so this is going to be way down here. You know, it doesn't have to be crazy. You don't have to be like, oh my God, that's too much. Oh, that's too little. Just show me a little bit. Even if it's 0.00, all I want you to do is darken the line, okay, for whichever one it is. Usually you'll see your 0.000 at the lowest or the highest value, okay? And then you have 0.041 for 1. And 2, you have 0.148. 3 is 0.283. 4.306. 5 is 0.176. 6 is 0.042. Okay, so it looks something like that. What's that? You don't have to darken them in if you don't want to. You can if you want. You know, on your quiz, your test, you have to do one of them, so just make sure you use a ruler. Make sure it's clear where they are, and sometimes you darken them in because I can't see where the top is because your pencil is too light. Just make sure it's very clear where it is. So on the left side is always going to be your probability. So you're not going to have to change this. It's always just going to be labeled probability. In this case here, Number of households. Okay, you got 6 households that you're talking to. And the title could be Households that subscribe to cable TV. Okay, any questions on that? All right, and we'll do more practice tomorrow on this. Okay, I got one little thing left to do, and then I'm done. All right, of course we have mean and standard deviation. So remember, there's only two sections here, 4.1, 4.2. Both of them have mean and a standard deviation. So it depends on what's given. It will depend on which formula you use. So your binomial mean and standard deviation, your mu is n times p, and your standard deviation is n times p times 1 minus p, which is n times p times q. So here's your mean, here's your standard deviation. Okay? What is the standard deviation squared? What's that called? That's your variance. Okay, so the book is going to ask for the variance. You might see the variance. So the standard deviation squared is the variance. Therefore, the variance is n times p times q. That's it. As long as you know the formula, it's pretty quick and easy. So again, Mary Kate, big game last night. So makes 80% of her free throws. What would the mean number of free throws be in 13 tries? Okay, so identify your n, your p, your q. What's n? 13. What's p? 0.8. And your q? 0.2. The mean? Your mean is n times p. So 13 times 0.8, 10.4. That's your mean. That's just your mean. Okay, that's all they're asking for. Okay, if you wanted to find the variance, okay, I was doing this just so we have more examples in your notes. So the variance would be 13, or you do 10.4, doesn't matter. So you have the 13 times 0.8 times 0.2. Thank you. And you have 2.08. And then square root of that. And what do you get for the square root? 1.44. Okay, that's good. Now, they could ask if it is unusual for her to make 9 free throws like it did on the earlier problem. Would it be unusual? How do you know? No, it has not the 0.05 this time. We're talking about mean and standard deviation. Yeah, the 2 standard deviations. Okay? So, min and max usual values, remember, are 2 standard deviations away from the mean. So, 10.4 plus 1.44 plus 1.44, that would give your max usual value. And then going the other way, the 10.4 minus 1.44 minus 1.44 gives you the 2 standard deviations below. Okay? So we learned that a couple chapters ago. It just keeps coming back. So here we go with the quarter problem. Okay, same that we did. So what is the mean and standard deviation? So again, identify NPQ. All right, so the mu, if you have to write it out, go ahead, write it out. The mu is 1. And again, just for practice sake, you have the variance. When you do the variance out, which is 10 times 0.1, which is 1 times 0.9 is 0.9. And then the standard deviation is the square root of 0.9, which gives you 0.95. Remember, your P of x goes 3 decimal places. Your mean, your standard deviation will vary. And then the last one is example 3. You can try that. Find the mean, the variance, and standard deviation. Identify your NPQ. Month of May. Yeah. So the trickiest part in example 3 is your N. 31. You guys have to figure out or be able to figure out how many days are in each month. You know how to do it? Knuckles. Yeah, that's why I used to use the knuckles. There's that silly little song. I don't know the song. Maybe Mrs. Toller would have it, but I don't know. She's a big singer. See right here, look, January. See this? Look, knuckle, knuckle. See? January, February, March, April, May, June, July, August, September, October, November, December. All the knuckles have 31 days. Okay? All right? So in between is, yeah. And how many have 28 days? All of them. I'm here all week, unfortunately. Okay. All right. All right, so your mean, variance, and standard deviation. Oh, I could put them backwards. What's going to be easiest? Oh, just be easiest to get rid of that. So you had your N is 31, P and Q, 0.44, 0.56. Okay? All good? So tomorrow, maybe I'll do another one together. Then we'll assign some problems. Take a quiz whenever you're ready. Start the problem set whenever you're ready.